Hello everyone, especially teacher and classmates. So this is our project today that we're going to do the presentation about, which is about student registration system. So here is our team member. We have me as the first presenter, Motanet, Mani, Siu Hong, Puteret, and Notisak. This is our table of content today. We have introduction, objective, our system design, data structure that we use for our system, demonstrations, and conclusion. So for introduction, our system, student registration system, is a console-based application developed using C++. So the system will manage student registration, course enrollment, and administrative approval throughout multiple users, including administrator, or we could say admin, student, and teacher. Another thing we could notice about this project is we use CSV file as our database, which is easy to implement, and we will also use a lot of data structure that we have learned from data structure and algorithm class. So our objective today, we have three. First is to develop a role-based student registration system that allow admins, student and teacher to affectionately manage student record, course enrollment, and academic information. Second is to implement a fundamental data structure and algorithm such as linked list, queue, stack, hash table, binary search tree, and sorting algorithm, which we will choose merge sort as our sorting algorithms. And the last one is provide an efficient and reliable registration process with fast searching, enrollment approval, undo functionality for students, and persistent data storage using CSV file. For our system design, this is the structure of our system design. We have database, which we store CSV, hash table, linked list, queue, sorting, stacks. Tool is the utility that we use, like reading CSV and something else. Define structure, tree, UI, and another one is main.cpp, which we tell where the computer should start. You can see the text that I put it in there. So for the structure algorithm that we use, we apply 6 data structure, and we could say 5 data structure and 1 algorithms. We applied linked list, double linked list, queue, stack, hash table for searching. Tree, we use binary search tree, and sorting, we are choosing merge sort as our algorithm for sorting. So what is linked list? Linked list is a linear data structure where elements are stored in a node, and each node points to next node in a sequence. Unlike array, linked lists don't require continuous memory allocation. Linked list can store an indefinite numbers of element and node, which we could say it is dynamic size. You can see the picture on the top right. It's a single linked list where we have one node, we have node, and we have one node which each node contain data and next. But this is the picture for single linked list. But in the side of project, we are going to use double linked list, which one node has next and previous. Inside the system for linked list, you will see a lot of linked lists inside the system. We use it for CRUD operation. We also use it to implement inside stack, queue, and for sorting as well. You will see a lot. So the first fundamental things about linked list is to create a structured nodes, where each node contains a structure of object, like student, a structure of student, a structure of teacher, a course or something. And like I said, we use double linked list. So we have next and previous. And another one is a structure for linked list itself. We have had tails. Count is to count how many nodes inside a linked list, and append here is to add at the end. We choose to implement add at the end. Remove it to remove the node. Clear is to clear the data, and many other things. So here just a brief explanation about the code. Append here is to add the node to the linked list. So we create a new nodes, and then we check whether if we travel to tails or not. If we reach tails, we set tails.next to point to the new node, and if not, we would if not, which means that the linked list doesn't have any node yet, so we take head points to the new node, and then the last one we take tails point to the new node also, and we increase, which means we add the node to the end. Remove the same, because we are using the linked list, it's easy to implement than the other. So what can we use? Like I said at the moment, this is the remove function that we have. So basically we can use it inside this one, because at the moment it's just a fundamental code. We can use it after we input something. There's a function called delete node. We check a lot of part where it is a student, a course, enrollment, or pending enrollment, or admin, and then we can call the remove function here, like I just show you at the moment. Another thing is the find data. Find data is like searching it. You would see it a lot in the next code explanation that my friend going to explain. And instead of implement everything and use it again and again, we just create one function, find data, and then we call it inside update node. This one is just a temporary display where you can display multiple students, and there's different way to explain, like sort by alphabet and sort by course ID or something. So that is all for linked list. I will pass the stage to my friend to explain the next data structure algorithms.
Good afternoon, good morning, teacher. So moving on, the next is queue. So what queue really do here is, so what the implementation in the system is that, so for example, if a student want to enroll enroll any course, so it's gonna add it to a pending table, a pending queue. So whenever the first student want to enroll that course, is gonna add to the queue, and the first one we're gonna apply the first in first out. Okay, so now let's take a look here. So for the important function we have here for the queue is we have enqueue, is to add an element or add anything inside the queue, and the queue is to remove it from the queue, and getFront is to get information from the head of the queue, and it's empty is just to check whether the queue is empty or full or not, and for the size of the queue, and clear is just to clear the queue. So display pending student here. So this is you can see here, this is table. So this function is gonna show you the table. You can see the information here. There's the course ID, course name, student ID, name, username, email, and status. So this table is gonna display everything about the student that in a pending situations where they enrolled inside a course and waiting for the admin to accept them. You can see here, if the student not found, is going to display unknown throughout this table, and here is just display the table structure. So this is where is really important function here. So this function first is gonna check whether your queue is empty or not. So if the queue is empty, which means there's no pending enrollment, which means there's no student that enrolls at the course. And here, if a list of students, so you're gonna have a choice and options for admin. So let's say there's a student are waiting for you to accept you to them get enrolled into the course. So if you want to accept them, you're gonna press 1 here. You can see here. So if you press 1, you're gonna there's a table, is the pending table and the enrollment table. So if you press number 1 here, it's gonna take a student from the pending table to the enrollment table, which means you accept it. So it's gonna remove 1 student from the pending table, so you're gonna left with 2 students. And if you want to reject the next student, you just can click or press 0. So it's gonna, you can see here it's DQ. And I forgot to mention here, and we press 1 here, you can see it's gonna append, it's gonna add to that enrollment table, it's gonna update it. Yeah, this one is a DQ, so which means that you're gonna take out from the pending enrollment and come back to here for reject. So it's gonna take the student out of the pending enrollment. And last one is number 9. When you click 9 here, you just go back to main page, go to this page, it gonna show everything here. So this is all for my part, and thank you for listening, and moving on to next part.
Hello teacher and everyone. Today I'm gonna presentation about the stack. It's one of the data structure algorithm. First of all, I want you to understand about what is a stack. Stack is the linear data structure that store data using the last in first out. It means that if the data at the last one, so that the data will delete the first one. Yeah, this is the example of it. If we have 1 2 3 and we add into the data, and the last one is 3, so if we want to delete it, it also we delete the 3 one. So it means first in first out, last in first out. And how it works in our program, it for the student enrollment, it's for the student enrollment and also for the student request. If the student want to enroll request, so they can do it. And another one, if the student want to cancel that enrollment, like it's waiting for approval, so they want to cancel that enrollment, so they can use stack here. And let's go to our code. Like in our program that we use, this is the function that we use that have push, pick, empty, side, and clear. This function we not write it directly, we just call it from the linked list. Like if we want to push, we just list append the data is, and it will go direct to the code, the linked list code, and it will add at the top. Also the pop, we check the empty or not, and we delete it at the top also. It means so if we add at the top, we delete at the top. And the pick here for looking for the last one is empty, check it empty or not. Get size is count the data, clear, delete all. And this is the first function that we have is student enrollment cost. And this is the parameter that we want to use. We get it for the linked list, also for the queue. It means we not write it directly, we just call it from our code friend. Yeah, it calls linked list, padding queue, session stack, enrollment, teacher, and first we just convert the cost from the CSV into the array, so we can display the cost. And after that, we ask student for the course ID, which ID that they want to enroll. So if they want to enroll, they just write the course ID, and it will check if that ID is validated or not. And after it's everything is okay, and after that it will go to check from the pending file. It means the pending enrollment file in here, and if the student already enrolled or the pending for the course, it cannot add another one. So if we cannot add it, but if we don't have in that pending enrollment, we can add it. Yep. And we write it into the CSV file also. And another function is student view enrollment. We have all the same. And first we just view the enrollment cost. We make it, convert it into array and display it. And after display that one, we also display the padding, the enrollment padding. So we display it, and after that we check if the padding enrollment is held data or not. If it held, we can undo it. Like we can cancel the enrollment So we can cancel it by using this code, and if it not, it will error could not undo. Yeah, and that's all for my presentation for the stack. Thank you.
Hello everyone, my name is Lisa and I'm in charge of explaining the sorting algorithm. Okay, so first of all, why do we use sorting in our projects? Okay, in our project we manage course and student records, and for example, the user, they probably want like to display the name of the course or the name of the student alphabetically. That's why we are using sorting in our project. And in our project specifically, we are using the merge sort and the insertion sort, and both of them has two job individually, differently. So before we getting any further, let's get to know what is the merge sort. Okay, so the merge sort work in 3 simple steps. First step is the divide part. So let's say, for example, you have this array 5, 3, 8, and 1. So the divide part is basically just split the array again and again until you will get one single array. Okay, and the second step is the conquer. So conquer basically is just the base. It's just the base case, and the next step and final step is the combine part. Once you get the single array, for example, you split them again and again, you will get 5 and 3. When you combine, it will loop for the smallest number to go in front. For example, you have 5 and 3, and then 3 will go in front of 5, and then you combine everything again, and the smallest number will go in front. So basically, that is just the overview of the merge sort. Okay, moving on, we will talk about how we implement the merge sort into our project. Okay, so as you can see the code on the left here, this is where we do our divide and conquer. Basically, it will take the data set, the courses or the student name, divide it again and again and again until it becomes a base case. And then this loop on the right here, it will this is where it will merge everything back together and back together again. So how it works is so basically when you divide the data, you will get two halves, the left half and the right half. This loop here basically compare the front of the left half and the front of the right half, find out which one is smaller, and then do it again and again and again until it's merge everything back in order. Okay, and that's it for the merge sort in our project. Okay, so moving on to insertion sort. So we also use insertion sort in our project, but it has a slightly different job than the merge sort. So the merge sort handle the full data set where the big scaling matters, and insertion sort handle small circuit result set where its lower head makes it a better choice. So each sorting algorithms has its own like advantages and disadvantages, so we are just using it on our situations, so we can get a better results. And that's it for my explanation of the sorting algorithm.
So hello everyone, my name is Siu Hong, and I'm tasked to do hash table and tree in the demonstration for our presentation about this student management system. So our hash table. A hash table is a data structure. Here the keyword is associative array with that store data in key and value pair. It uses a hash function in order to put all these map all this key and value together. And then the best time complexity of this structure is O1 constant time. It's also the average time complexity. So in our system, we use hash table for a fast course lookup for student, and also a prefix-based student search for the teacher and admin. So here we can take a look at the code. This is the header file. So it's just like a abstract without the implementation of the actual code. But here we have our structure of our hash. We have a key and a value like this table. And then here inside our class, we have the size of the table. I set it as 101 because it's big, but it's also small to not take up too much space. And then we have a hash function where we implement changing alphabet into its index, into a number. And then we have an insert and of course a search. We could search here, search exact. So let's say the name starts with Alice, I can search with A. And then for partial search, let's say the course is linear algebra, I can search for LN, or NI for linear algebra. And then I can clear, and then we have a destructor to call out the clear. Here we have a student search course, and so student can search the course and teacher can search their student. Next is tree. A tree is a non-linear hierarchical data structure consisting of nodes and edges. Node will be this, and edge are this line that connects the node. And unlike array or linked list, it stores and organizes information across multiple structural level. You see the level here. And inside our system, our student system, we use tree to alphabetically sort the teacher from sort the student from A to Z for the teacher. And our code implementation, we have a data left, right. So this is the left, this is the right. And then we have the root here. We have a constructor, destructor. This destructor called this destroy record, and then the rest we have insert, and this two is this one would call this collect in order record, and this one does the logic in order to collect the student record in order. And then we also have a teacher view enrolled student, so the teacher can view the enrolled student and display it. And next, onward to our code implementation. So we compiled it. Oh, sorry. Then we run it. So firstly, we log into the system. I want to explain my previous friend's part 2. So first we go linked list. So linked list is related to CRUD. Here we log in as admin first. Admin, and then admin. And then we can add student. So let's say these are the existing students. Some are enrolled, some are pending. We can add more students. Let's say my name is Hong. Username Hong. Email hong@gmail.com. Password, let's say pass123. And then here I have been added into this system as well, but I'm pending. I'm not enrolled yet. I didn't sign up for a course yet. So that's a little bit about the linked list part. You can also update and delete, but we're not going into detail for that yet. And next is queue. So the admin could see the pending enrollment, and then here they could dequeue the student. So first in, first out, you can dequeue the student and then push this student to enrollment. Before it was in pending, soon it will go into enrollment. So if I click 1, notice that this C03 will be gone. Now C03 is gone and is put inside enrollment. So that's a little bit about queue. Next is stack, is related to undoing. So this we have to log in as student. I have one student named alice.j. I memorize it. So her password. We're logging in as student. So here I can see the available course, and I'm going to enroll, and as I enroll, it will push me into pending enrollment. Okay, let's say C002. So now I'm enrolling this course. So here I've successfully added into the pending list. So I need to wait for the admin approval. To check that I have enrolled, I can view my enrolled course. I have enrolled in a course called Introduction to Programming, but I'm still pending, waiting for the admin for data structure 002. So that's about it for stack. Oh wait, no. So I didn't show you the stack yet. Here, let's see. I undo it. This one will be gone. Okay, so now I'm gone. Then there's no course found here. So next is hash table. So this one is related to teacher. So I need to log in as teacher. Sarah. The password. And now I'm logged in as Sarah. I can view my student here, right? And then I have one student named Alice, and I can search up using hash table. This one, I can search the student name. So let's say I miss search or search L, so it would not exist in the table. It's not found, right? But then if I search with A, you will see Alice. Yes, Alice Johnson. So okay, so for tree, we want an alphabetical sort. So this one is only for the teacher. The teacher can display the student in alphabetical order. So I need to sign in as the teacher, Sarah, password 123, and then now I'm signed in as Sarah, and I can view here inside the database. I've made some changes in order to display. Before there was only one student named Alice. Now I've added more student into teacher Sarah course, and I've also arranged it so it's not in alphabetical order. But when I display it, it will still display in alphabetical order for me, like that. And that's all for tree, and that's all for my part. Thank you.